All right, geometry students, it's a quick one today. We are to the point where we are done with all of our Chapter 9 and vector notes. So we have our gold sheet out. The front of the gold sheet you were using for Chapter 9 notes, the transformation notes. And I'm going to be honest, it's all filled out for us, but just a quick highlight of a couple things. When you go to remember that isometry here is when a transformation preserves length and angle measure. And remember that a translation is isometric, a reflection is isometric, and a rotation is also isometric. So those three never change that shape in that. And remember, when or if we do any type of assessment with these, I will give you these coordinate notation notes. So you don't have to have them memorized, you just need to know how to use those. And then the last and final one is a dilation. That is not isometric because it does change the side lengths. So remember, when we do a composition here of transformations, that as long as the transformations included are isometric, then the composition of them is also isometric. So that was the beginning of the chapter. Let's flip the paper over because we have blanks on the back. And let's talk about this vector stuff we've been doing. Let me erase that mark I just made. All right, vectors. So hopefully you watched that little video clip and enjoyed it. It's a lot more fun to show in class and helps us all remember what the two parts of a vector are. So just writing them down here, a vector is a quantity with both magnitude and direction. And a couple more reminders here on the vector notes. To name a vector, you want to put the initial point first, followed by the arrow point, and you use a symbol, which is a line with a half arrow above it. So if you had a vector that looked like this, let's say it was named like this, we would start with the initial point, which is B, then we go to where the arrow is, and we put that half vector or half arrow above it. And the order definitely matters when you name those. Component form tells you the horizontal movement followed by the vertical movement. So if I have in my pointed parentheses, remember, don't put parentheses because it looks like an ordered pair. So anything left or right, left is negative, right is positive. Anything up or down, and down is negative, up is positive in those pointed parentheses. So if I had something like, I don't know, I'll do like -6, 3. Remember, that's not an ordered pair. It tells me from wherever I start, I'm going to go left 6, 1, 2, 3, 4, 5, 6. And then I'm going to go up 3 because it's positive. And there's my vector, this blue line here. This is my vector, my arrow. And this is all direction and how I go. So we know there's two parts of a vector, the magnitude and the direction, and we have to be able to find both of them. To find the magnitude or the size, that's what that means, of a vector, we're going to use the Pythagorean theorem. Or otherwise known as a squared plus b squared equals c squared. So if I have a vector something like 2, -5. Okay, if you think about it, I start here, I go right 2 and down 5. Here's my vector, okay? And then to find its size, this vector is actually this line. That's my c, and I'll do a squared, b squared, c squared, because remember, this makes a nice little right triangle. And then to find the direction angle of this vector, we're going to use tangent. And remember, the angle always comes from the initial point. So up here by this initial point, here's my angle. And from this angle, you'll notice this 5 over here is opposite. The 2 over here is adjacent. So that's why we're going to use TOA or tangent. So we would say tangent of the angle equals opposite, which is 5, over my adjacent, which is 2. And we remember that if we want that theta all by itself, we'll take the inverse tangent, okay, of both sides. So what we end up doing is doing inverse tangent of 5 over 2. Quick note, because I don't think I said this when we took notes originally, this 5 was negative because it told me to go down. When I plug it into tangent, never plug in a negative in that tangent. Always just plug in the distance, which is 5 over 2. So please don't use the negative in the tangent. If you happen to use the negative in your Pythagorean theorem, it's still going to work out okay because when you square it, it becomes positive. But please try to remember, don't use the negative in the tangent. And at the bottom of this page, we'll notice that we have the rest of these notes about scalars and such, how we're going to use those when we add or subtract vectors together or multiply. And again, those notes are there. You just need to know how to use those. So I'm hoping that your review pack goes well today. And again, please send me any questions or concerns. And once again, if you didn't go watch that little video clip from Wednesday, please do. Have a great spring break, and I will be communicating with you again starting on the 14th, and we'll go from there to see what our new classroom looks like. And I just will give you the heads up, we will have work that must be turned in and graded, so we will see some changes, but I hope to still be making you videos, and maybe we'll add a Zoom chat in here and there. Have a great break. Enjoy it.